The Hong Kong-Zhuhai Macau Bridge is a mega project stretching over 55 kilometers, built right in the middle of one of the busiest seas on the planet. It was once considered an unrealistic idea, as nearly every factor was against it, from powerful currents and weak seabed conditions to the immense pressure of the ocean that could crush any structure. While much of the world remained skeptical, China moved forward and turned that blueprint into reality. This mega project cost more than $19 billion, has a design lifespan of up to 120 years, and is comparable in scale to linking dozens of ordinary sea-crossing bridges together. So how did Chinese engineers manage to lay the foundation and assemble such a massive transportation system in the middle of the ocean? Let Mandarin Tech take you through the answer right now. The Hong Kong-Zhuhai Macau Bridge is one of the most ambitious sea-crossing infrastructure projects ever built, stretching over 55 kilometers across open water. This megastructure connects three major regions, Hong Kong, Zhuhai, and Macau, forming a single integrated transportation network. What makes this project truly extraordinary is not just its length, but the extreme conditions under which it was built. Engineers had to deal with powerful ocean currents, soft seabed conditions, and one of the busiest shipping routes in the world. At one point, many experts believed that building such a structure here was nearly impossible. Yet China pushed forward and turned this once unrealistic idea into a working reality. Before any visible structure could rise above the sea, engineers had to solve the most critical challenge, building a stable foundation underwater. The seabed in many sections was extremely soft and unstable, making traditional construction methods unreliable. To overcome this, engineers used three primary techniques: pile foundations, cofferdams, and caissons. Among these, pile foundations played a crucial role by transferring massive loads deep into stronger soil layers beneath the seabed. Cofferdams allowed workers to create dry construction zones in the middle of water, while caissons acted as giant pre-built foundations that could be placed directly onto the seabed. Each method was carefully selected based on location, depth, and environmental conditions, ensuring maximum stability for the entire bridge system. Once the foundation was secured, construction moved upward to form the bridge structure. The project includes massive cable-stayed bridges combined with long stretches of beam bridges, creating a continuous roadway across the sea. However, a major challenge came from the nearby Hong Kong International Airport. The bridge towers needed to be tall enough for large ships to pass underneath, but they could not exceed strict aviation height limits. To solve this, engineers adopted a unique method. Instead of building towers vertically, they assembled them horizontally near the water surface and then lifted them into position using advanced cable systems. This precise and controlled lifting process ensured both safety and structural accuracy. In certain sections, building a continuous bridge was not possible due to heavy ship traffic and strict airspace regulations. To overcome this, engineers introduced a hybrid solution, combining bridges with an underwater tunnel. But this created another challenge. There was no natural land available to connect the bridge and tunnel sections. The solution was to build artificial islands in the middle of the sea. Engineers installed massive steel cylinders into the seabed and filled them to create stable platforms. Even after construction, the bridge faces constant environmental challenges. Strong winds can cause dangerous vibrations, while heavy marine traffic increases the risk of collisions. In addition, saltwater corrosion poses a long-term threat to the structure. To address these issues, engineers used high-durability concrete, corrosion-resistant materials, and advanced damping systems to control vibrations. The bridge is also monitored continuously to ensure safety and performance. With a design lifespan of over 120 years, this mega project stands as a symbol of modern engineering innovation, proving that even the most extreme natural challenges can be overcome with the right combination of technology and creativity.